Hey again, everybody. I am going to do a brief screencast showing you how I see. I apologize. I've got a 2-year-old running around, baby sleeping, and I'm at home, so I'm just going to go with it. Showing you how you're going to complete this project. So this has been assigned to you. This is on Schoology. You're going to be using the Gizmo application, which you've already signed in, and you already have your username. So explorelearning.com. You're going to be using, excuse me, the Growing Plants Gizmo. Okay, so you're going to be using the Growing Plants Gizmo, which you've already completed a little warm-up activity for, so you know how you can manipulate the variables and so forth. So the handout is a Google Doc that you'll be following, and it says Growing Plants Project. This is different from the warm-up activity that you've done. You need to read and reread the instructions. Okay, this is an individual assignment and it counts as a major grade. So this is instead of a typical test that you would have at the end of a unit. We're going to be using this to assess your understanding of the scientific process. You can use your student packet with all your notes on testable questions, how to write a hypothesis, identifying variables, the difference between independent and dependent, and everything. You have access to that. It is completely open note in that regard. Okay. But it needs to be your work and your work only. There are some steps that you're going to follow. The first step and the most important step is to determine the question that you want to investigate. This question will guide the rest of your project. So my hint to you right here is your question is going to investigate one of the variables. So you have the amount of water, the amount of sunlight, the seed type, or the soil, and how it affects the plant's height and mass. So as you recall from learning about variables, independent variables, when you run an experiment, you only want one independent variable. Why is that important? The reason why it's important is that if you have more than one independent variable that you're manipulating on purpose, then you cannot actually conclude your experiment and say, this is what caused the results of my experiment, if you have more than one thing that you're manipulating. So you only want to change one thing. So you have some choices here. Maybe you want to manipulate the amount of sunlight, okay, for your plants. You have 3 setups, and yes, you'll be using all 3. Maybe you want one plant completely in the dark, one full sunlight, and one partial sunlight. Okay, that would be your independent variable. Maybe you want to, if I turn these lights back on here, maybe you want to manipulate how much water the plants get. Maybe one gets full, one gets middle, one gets none. Okay, that could be your independent variable. Or maybe you want to have manipulate your seed type. You want to have one plant have a tomato seed, one have a bean, and one have a turnip. Or maybe you want to manipulate your soil type. You'll have one with no fertilizer and compost, maybe one with fertilizer, and maybe one with compost. Okay, so you choose what you want to manipulate, and that guides your question. So, for example, how does the amount of sunlight affect a plant's height and mass? Or how does the amount of water affect a plant's height and mass? Okay, your question is going to be something very straightforward like that, and it should only have one independent variable. From the get-go, if you say, how does the amount of sunlight and water affect a plant's height and mass, you're already setting yourself up for an incorrect conclusion, and unfortunately would lose a lot of points, because one of the biggest things to walk away from this unit is that you can only have one independent variable in an experiment. So that's your biggest thing, is developing your question. And it's going to be on one of those variables. Step 2 is define your variables. So what is your independent? Is it type of seed? Is it soil type? Is it amount of water or amount of sunlight? It will be one of those 4. One of those 4. Your dependent for everyone is going to be height and mass, and your controls are everything else. So for example, if I'm going to manipulate the amount of light, okay, listen carefully here. This is really important. If I'm going to manipulate the amount of light, then I would want to make sure, say my plant A has this light on, plant B has full light, and plant C has 2 lights on. Then that means that should be the only thing that's different for my 3 plants. Everything else should be the same. So if I'm manipulating the amount of light, okay, then that means that water needs to be the same for every plant. So if I do 50 for this plant, I need to do 50 for this plant and 50 for this plant. If I'm using a tomato seed in this pot, then I need to use tomato seeds in all pots. If I'm adding fertilizer to one pot, then I need to add fertilizer to all pots. So if I'm setting up my experiment here, you can see that I only have one independent variable that is manipulated in this setup. Everything else is the same. So these are my controls. If sunlight is my variable that I'm changing, then my controls are water amount, seed type, and soil type. Okay, everything else needs to stay the same. So I'm going to clear my pots here. And I'm going to start over there. Okay, so that's really, really important to do that. Okay, here, can I see Smokey? Huh? Okay, well, shh. Okay, then you're going to write your hypothesis in the if-then. So for example, if I change the amount of light that my tomato plant receives, then the tomato plant with the most light will grow the tallest. You could have a different variable for every, you could have a hypothesis that varies in so many ways for the variables that you're testing. Just make sure you follow that if-then. Step 4 is to write a procedure, a very basic procedure so that anyone could duplicate your investigation. So you need to make sure you don't assume that anyone knows any of those steps. Hold on one second. Sorry, 2-year-old. Okay. What was I saying? Run your investigation. Okay. Procedure. So down here in the Google Doc, you're going to be writing steps like step 1, step 2, step 3. So you need to write a simple procedure of how you're setting up your gizmo. Place a tomato plant in each pot. Okay. Add fertilizer to each pot. Make sure the water is this. And in pot A, no sunlight. Pot B, 2 light bulbs. Pot C, etc. So you're showing me how you set up your experiment. The next step is going to be collecting the data. So I've already given you a basic data table that you'll be filling in. So you'll notice that you have your 3 pot setups. You're going to run 3 trials. Yes, 3 trials of the same exact setup. You do not change your setup in between trials. And some people might say, well, am I just going to get the same results? It's computerized. Well, you may or you may not. That's one thing that you'll kind of discuss is this is a computer simulated system. Okay, you need to be quiet. Shh. Okay, I'm sorry. Shh. So still run your trials. You may or may not get the same data, even though you have the exact same setup, but do not change your setup in between trials. Don't do trial 1. I'm going to have this setup and then do a completely different setup. You're doing the same setup 3 times. Okay, the same exact setup. You're following your same procedure 3 times, and you'll be filling this out. So how does insert your independent variable here? So whatever you chose to test, you're inserting it there. Affect the height and mass of, and then your plant seed there. So whatever maybe your plant seed is your independent variable. So maybe worded a little bit differently because that could be your independent variable as you change the type of seed in between each pot. Y'all, this is going to take forever. I'm having to pause a bunch of times. You take the average. So for pot A, if your height, for trial 1, 2, and 3, you add them, divide by 3, get your average. The mass, add them, divide by 3, get your average. And then you're going to graph. So you're going to do this on a sheet of paper, okay? Neat, color coordinated or with a key. Follow my instructions here. And you will take a picture of it and insert it into this doc. And then the conclusion is the final thing. And I'm not giving you a guide this time, but you will have the guide that you wrote for the Skittle experiment can be used loosely as a guide for this. Your conclusion per the instructions here that I have up here on your Google Doc is that the conclusion should be 2 paragraphs. The first paragraph discusses your setup and your results, like you're just restating your data. The second paragraph is more reflective, like, what would I do differently? What were my sources of error? And you might say, well, your source of error, we didn't run this, this was a computer simulated source, a gizmo. So that could be a source of error because, computers aren't perfect either. What you would do differently, what you would learn. So 2 paragraphs. use the Skittles model conclusion as a rough outline for what your paragraph should be, what your conclusion should be for this. Okay, so the important thing in your conclusion is that you're looking at your hypothesis and you're comparing the data to it. Did the data support your hypothesis? Did the data not support your hypothesis? So you want to make sure that you have a strong question, that you have a strong hypothesis, because everything else is going to bank on those two things. And if your question is weak, your hypothesis is poorly written, then it's going to be really hard to properly conclude your results and be able to compare them to your question and your hypothesis. It needs to make sense. So this is something you really want to take your time on. This should not be rushed. You will take, probably 2 whole class periods to complete this. Once, if there's time, I'm going to provide you with a peer edit before you actually turn in your final, where you're going to have a peer go over your experiment, and they're going to have a sheet where they're kind of checking off and helping you see some mistakes before you actually turn this in. So just like, a paper, you would have a peer edit that paper to help the revision process. It's very similar when you're running an experiment. You want someone with, a different set of eyes to look over it and to help you kind of go through a checklist. So that will be part of the process as well. So you cannot, turn this in until that's done. And my goal is that we could turn this in before fall break, but if we don't, it's okay. Okay. Miss Knuckles and myself will talk about it, and we will determine the turn in date for this. So at this point, she, will instruct you to open up this Google Doc. The assignment is on Schoology. You open up the Google Doc. You have a separate tab open running your experiment. You need to think about and go through the steps. What do I want to test? What should my question be? You are simply typing in this Google Doc. Okay, if I determine my question is, how does, sunlight affect blah, blah, blah. You type in right here in this Google Doc. Okay, so hopefully this makes sense. And I am done. Yahoo!